So for this Let's Model practice data set, I downloaded this from the website, the Destaco website, and it came in as a step file, converted it to Inventor so they're all just dumb solids, and then made a print for each part. And this is what we're going to attempt to model. So let's get started. Alright, so let's just start at the beginning and do the right hand lever. So I'm going to start with a new part. This one is in inches. I'll put together a metric print as well when I post the PDF. So I was originally going to cut this out as a rectangle and start chopping away at it. But because a lot of the stuff's based off of the tangencies, I think it, in this case, might be easier to draw the overall shape. So I'm going to start with my 0, 0 being that big hole in the middle bottom there. So that's going to be my 0, 0, that hole. And then the back side is 0.313. It's horizontally aligned and 1 apart. And then I think I'll just draw the rest. Now that top dimension 4991 goes down into the fillet here, but it shows the extension line, so that's going to where they intersect. So I'm not going to draw that fillet, and I'll add that fillet afterwards. The rest of the fillets I'll draw. And I think so that I can show a full round, I'm not going to put the full round on the end. So this would be, I'm going to hold shift so I get tangent to tangent. Why is that going uphill? Oh, I drew the hole instead of the outside. So 0.375, that looks better. All right, let's finish this shape off. So I'm going to say tangent up to here. I'm going to let go of shift. And then if I go back on the point, your dot turns gray. When you click and drag, you pull a tangent arc off. And do something like this. Keep it simple and sloppy. A little too sloppy the way this is going. Then it goes horizontal for a bit. And then I'm going to do a coincident constraint, point to line and tangent. All right, so let's dimension this up. I know this is 1.438 and off of, well, let's do, this is a big dimension. I like to do the big dimensions first, and that kind of sets the shape. Overall length is from center. And we've got a, we don't know that, but we know this. That's off of here. And this is 0.625. Missing a tangent the way that looks, so I'll do that while I see it. F8 shows my constraints, so check my tangencies. The rest look good. F9 turns them back off. So keep kind of working my way back here. This is 2.94 and a radius of 0.5, and I am fully constrained. You wouldn't have to trim this out. In this case, I don't think it's going to hurt if you trim them out, but I'm going to leave them. It's not hurting anything. And extrude, and then I'm just going to window select this whole thing and do my thickness 0.156 times 2. Something like that. Put the holes in here next. Concentric, so you just pick the face, pick something round, simple hole, 0.314, space bars, repeat last command. I wish Fusion could figure that out. And before I forget, we'll throw my fillet in here of 0.12. And we need our full round fillet, so we'll do a full round fillet. Why can't I find it? Tangent G2 inverted. Oh, I remember where they put it. I remember. It's underneath here now. Ugh. There's your full round. I think that might be a 2023 thing. So you just pick your 3 faces going in the direction of the curve, and there's your full round. That's our overall shape. Now we need to cut these bends. And originally I was going to put a sketch on this face and draw a line and use bend part. Then bend the top, and then go to the other side and bend it back over. But I don't have an angle on this, just given heights. So I'm stuck with drawing lines. So this side is going to have a line that will be the lower one. And we need the bottom here. So I think that would just be tangent to this. Hey, I projected you. So dimension to tangent. Try it again. Dimension to. There's my tangent. The lowest point. 0.839. And then we'll go to the other side. Oh, so I was talking about using bend part, and then I started doing bend part. So let's start over, and what we're going to do is we're going to cut out the voids here and make it look like we bent the part. So let's start over. So I'll put a sketch down through the center there, and let's see, project this line. I think I want that line. That's the lowest point, I think. And then I'll draw a line off of it. .839, and no, that's not what I want. I want to line up the center, 0.839. And then it's going to go something like this and then come down here. And then we'll project the top point, and we'll come down from the center. Help if I leave my space bar alone. This is 1.196. I got 2 points in there. And we'll finish off the shape. I guess I didn't have to do that second line. And then to set this angle, I think the only thing that we can do is say these are parallel. And we know the thickness. Oh, hold up. So I see I did something wrong. So the thickness of the part is 0.156, but then it bends over 0.159. And I did this extrusion as 0.156 times 2, and it would actually be 0.156 plus 0.159. And then, shoot, that means they're no longer in center. So we got F8, and we need to make these no longer on center. All right, so we can move him, and then we'll put him back on, not in the center. And this will be the thickness of the cutout, 0.159, a little bit over center. And then this, gonna move it over here, then back down, not in the center. This is a cutout, and the cutouts are 0.159, so a little bit more than the thickness. And then this would be the thickness. So now we should have a consistent thickness down through here. And we can cut in both directions. Way through all as a cut. Okay. And then we have a 0.06 inner radius. And then the outside would be 0.06 plus the wall thickness, 0.156. I think we got that part done, so I'm going to say save. That's the what I downloaded to get the measurements. We're going to save it here. I just downloaded this off of Destaco's website. And this will be, I'm going to just name these lever right hand. And we need a left hand now. And I can say, let's look at my planes. I want to mirror about that plane. Is that right? Yep. So I can say mirror when I make a part. So make part using this body and mirror about the XY plane. And it's going to go in the same folder, and it's going to be called lever left hand. So left hand's going this way, and oh, I put it in an assembly. So I think I'm going to just open this part. There's a checkbox to not put it in an assembly. And then I'm going to delete this and not save. So now I have a lever left hand and a lever right hand. And the left hand is actually derived from the right hand. So any changes you make to the right hand will be reflected in the left hand. But I got two parts done. So save it. And that's the first one. We'll go to the link, page 2. New part, new sketch. I'm going to do this the same way. I'm going to start with the front view. I'll do a center point slot. And this is 1.75 divided by 2. And the diameter is 0.62. There's our overall shape. We can extrude that. 0.295. And we'll put our holes in it. 0.315 and 315. Then we just need to cut it to make it look like it was a piece of sheet metal. And we can do the same thing we did before. So everything's off this side, so I'll project this edge. And yeah, we'll just do this in chunks. We'll keep it simple. So I'll draw my cutout, make that horizontal, and from here to here, I have 0.185. And then we have a notch that's in the center, so I'll vertically align there to midpoint. So that vertically aligns them. I'll put an equals between these and a parallel between these. Then we'll add some dimensions. And I just know my thickness is 0.185 and this is 0.63. Oh, I see. I think I can assume this is this. So 0.295 minus 0.185. Yeah, I think that's what I'm missing. And that's an assumption. No, that's not an assumption because I have to have a continuous wall thickness of 185. So maybe a better way of dimensioning this would have been 0.185. All right, finish sketch. Let's see, extrude. We'll say through all. And then I'm going to mirror. that to the other side. Quicker than trying to constrain all that additional geometry. 0.03 on the inside fillet. And then the outside fillet will be 0.03 plus wall thickness. And there's our link. Let's save it. Oh, I saved it as part 1. Let's just do save as. Our next part is the plunger. Obviously, we'll start with a shaft. And 625 extruded 4.25. I think my mouse batteries are dying because my mouse is not responding to me very well. Let's put that hole through on the end here. So we'll put a sketch on that. We can slice the graphics so you can see we're actually in the center. Draw a circle that's got a diameter of 0.314. We want to line it up from origin point to center point, and then we need a dimension off the end. That's it. Extrude it. We'll go by mid-plane or symmetric and through all as a cut. Now they have this 45-degree taper on there. 0.0625 at the deepest. So to do that, we're going to need to put a sketch on the opposite plane here. Slice our graphics. And draw a little triangle is what we're going to have to do. So project U and U. And we're going to draw a triangle that is 45 degrees. And it is 0.063. It's probably 0.0625. And we'll revolve that around this axis. I don't have an axis in there, so I need to first make an axis. So we'll grab the axis command and just click inside. And now we have something to revolve around. So, oh, and now I should still be able to pick that. Got my profile. Does the axis have to be above the sketch? It does have to be above the sketch. Cut. Okay, so that's what they did there. They ran a 90-degree taper tool down inside it and just deburred that a little bit, I guess. We'll mirror that to the other side. And then we got our nice little cutout. I'll turn the visibility of my work plane off, or axis. Then we have a little V running around the other side. So we'll get another sketch through the center, slice my graphics, and we're going to draw, I'll project this top edge, and then draw a triangle. Put an equals between them. And then dimension it. And I tell you what, I'm going to project this axis Yeah, because I need it. I need this for my depth. That section view shows me the ID of this is 0.564. Would you call that the ID? It's the OD, but it's inside the overall OD. And then it's 90 degrees, and then this should be fully constrained. Oh, we still need how far over it is. 0.23. Ready for a revolve as a cut. And there's our little notch taken out of there. We'll throw some chamfers on these edges, and we're getting close. 0.06. There is a hole on this end, and it is not a through-all. It is 1.44 deep, and a diameter of 313. Okay, I think that part's done. Save. Bushing's an easy one. You don't really even need to see me do this one, but I'm going to need it done, so let's do something different instead, because it's just a cylinder. So instead of starting a sketch, I can right-click on my ribbon and show panels. Everything's opening off of the screen here. And turn on primitives. So this, if you're doing a lot of these, you could turn on your primitives and then say cylinder, pick your sketch, pick your plane, pick your origin, type in your diameter, and then it automatically extrudes. If you're going to do a whole bunch of those cylinders, that might be faster for you. Through all, 0.316, and some chamfers. All right, that piece is done. This rivet, you probably wouldn't model like this, but I mean, this is modeling practice. So this is how it came in from their website. So this is how I'm going to model it. So we're going to model a compressed state rivet. And we'll start with a cylinder because we got those primitives, might as well use them. I'm going to do the left-hand side first, so 0.5, and it's extruded 0.093. And then I'm going to do another primitive cylinder on this face. And the diameter is 0.312, and it's extruded 1.093. And then we'll put a sketch through the center. Slice my graphics, and we're going to draw. Let's make it match the print. We're going to draw, all the dimensions are up here, so we're going to draw this lip right here. So get some projections to work with in case we need them. It looks like it is 2 circles. With the inner circle being tangent to here and vertically aligned to that point. We just need what it ends up being. The inside is a radius of 0.031, and we have a wall thickness 0.032, and then I need a line that runs up through here, and then I can trim you and you and you. That is my shape that I'm going to revolve, and it's fully constrained. Thumbtack in the sketch, fully constrained. So we'll go to revolve, and our axis will be the Z in my case. And then we'll put a hole in here. That is 1.093 minus 1.047. And it does go to a point, and the diameter would be 0.248. So there's our rivet. The grip is gonna be fun. New part. I'm going to do this as a revolve, I think. I'll do a center point arc. And then something like this. And there we go. Get that lined up. So this is 0.531. Overall length 3.311. Might as well turn this into a center line. So here to here is 0.819. And the reason it's not fully constrained is because I'm missing a tangent. And if you can't figure out, it still says I need one dimension. If you can't figure out what's going on, just grab the lines or grab a point and move it. And then you can quickly see, oh, I see what the problem is. Don't move it right back here and then fix it. Leave it off. Why are you freaking out on me? Leave it off and add the tangent so you can see it snap into place. And now I'm finally fully constrained. So let's revolve this. Let's cut out the insides before we start messing with the wording on the outsides. And okay. So I'm going to draw a slot and just get started here. So do a 2-point slot and get it lined up. in the center. And I know this dimension is 0.315. Is this? Yeah, that's lined up. And then I know the overall length is 2.339. And then I'm missing a dimension. So let's just put it there and see what happens. No, it's not going to be right. It's going to have to go past that. We'll give it a dimension. We'll try that. Let me see what this is going to look like with the bigger slot here. 0.295 times 2. Yeah, I like that. Let's say that's 0.125. Extrude, it's fully constrained. So we're going to go symmetrical, cut, and 0.402. We'll put a sketch back on that same plane and slice our graphics and then do the next cutout that is not quite as deep. And I'm going to project this edge and I think that's all I need. So I'll get my circle, and this is going to be 0.295 times 2. And the line comes off Yeah, I think what's happening is the line comes off straight. And then it jogs out and then continues straight for a bit. We're going to go the whole way out. Add some dimension or some constraints. Those are equal, those are equal, those are equal. And then we just need some dimensions. So that is 1.063 and this is 1.22 and this is 0.618. I think that's all I'm going to do there. So extrude it as a cut, but this time 0.276. Let's see what that looks like. And then add some equals between these. And this is 0.674. Why is that not fully constrained? Oh, I see. Okay, so we need a horizontal and an equals between you two, maybe. So let's why is this kicking my butt? Yeah, so I just want to do, that's going to set that opening. So we'll say both directions and cut. Yeah, I could have put that in the last one. So that flares those two. All right, that's not going the way I wanted it to go. So let's put a sketch down here and just try doing the same thing. So project you and you. And I'll draw a line out to here and a line out to here. And make them equals. And this is 0.415. I think I got it. I think that's the shape. It should taper out in all directions. Yeah, it is. It's tapering in all four directions. So I think that's right. I spent too much time on that. Let's do this text on the face. So I think the first thing I'll do is cut out the oval that has the word Destaco in it. So first I'm going to get a plane up here where I can work. So I'm just going to pull a plane up here in space, put a sketch on it. get it lined up, and dimension it up. We'll do probably something like that. Again, I'm missing a dimension. Do another 0.125. That worked out for us last time. And then the center to center is 1.973. And we're going to let's see. Let's extrude this as a surface. And split face, that's our tool. We want to split that face and that face. And we'll turn our surface visibility off, and we still want the, well, let's turn the work plane off. All right, so now if we thicken that and that down 0.031 as a cut, is that going to give us what we want? I think that's close enough. All right. I would have mirrored it, but I had to cut the face, and it cut, since it's round, it cut both sides. So let's get rid of that other split. We don't need that anymore. Probably not a bad idea to save this thing at this point. Good Lord. All right, back on our work plane. I'm going to try just the T, because the T is going to be dead center. First, I need to figure out what dead center is. So we'll make that construction and put a point in the center. That identifies our center. And the letters are all 0.04. And we're going to make a T. So rectangle, actually, we could do a center point rectangle here because this one's dead center. So point, the height of the letters are 2.12, and the thickness of the lines are 0.04. And then a rectangle is going to go across the top like so. So this is 0.04, and this is that. And then I need to constrain them together. Now we got to figure out how to get that down on there so that it wraps and it is only 0.031 off the surface. And to be honest, I could extrude it as a surface and let's project it to the surface, cut the surface, and thicken it. I have an idea. If I put a boundary patch on here and said tangent, I would have the same surface that I would have had. Then I can say extrude U and say there and man, I used to know where all this stuff was. There it is. There it is. So from there to there. I just can't get used to these panels yet. All right, so that should be curved but straight on this tapered cylinder. Okay, so now I think we know how we're going to do the letters. And quite frankly, I think we just do all the letters on one sketch. Yeah, I think I'm just going to do all the letters on one sketch because they're all going to work off of each other and none of them are overly complicated. All right. Save. So let's edit this extrusion. And I can't window select everything, so okay. And I'm going to turn off this boundary patch, and I think I have that, but I don't think I can't mirror that because then my text will be backwards. Yeah. So let's try a circular pattern. Of 2. All right, and then that should all stick out. A consistent thickness. Same thickness as my thicken. Anyway, I've wasted enough time on this. Let's change this to red. And save. Actually, is there like a red rubber in here that we can pick? Copper, dark red. Doesn't look dark red, that looks clear red. This'll work. Alright, save it. Whew. Oh, we're not done yet. There are ears cut off of this thing. So project you and you. There's a 45. That is from here to here, 0.415 divided by 2. So I used the wrong dimension down here. I'm going to go fix that. I spread that too far apart. That's supposed to be 0.331. Now I can extrude this symmetric through all cut. Okay, and I will mirror it about the XY. Mirror you about XY. Okay. Am I done now? I think I'm done now. Alright, I got 2:17 in the morning. I am going to break until tomorrow to do the last part. Alright, we're on the last model. So this should go better. Do a center point rectangle for this base 5.031 and 2.265. And that's going to go up 0.182. And I'm going to do the left side first. I think I'll do the build up on the left side. So I'm going to project an edge and do a center point rectangle to that edge. Make sure you don't get to the, I guess you wouldn't get to midpoint there. 0.765. It's going to go up 0.402, and then we'll, oh, that's not right. That's too high. Oh, minus the base. So 402 minus 0.182. And we'll put a sketch on this guy. And no, I think I'm gonna undo that. I think I'm gonna draw the piece that sticks out here next. So if I go back to the point, click and hold, I go into my arc and end on the line, and I'll add a tangent and dimension it up. Oh, come on. I want it to snap to center. And this is... All right, we are fully constrained. Extrude that symmetrical and 0.312. I'm going to put the hole in while I'm here. 0.314. And I'm going to do the next piece that's built up on here. I'm just going to project the whole face, I think, and I'm just going to do the one side and mirror it. So it looks like it goes something like this. So this is 729, and that is 1.609. And 0.505 divided by 2, and we're fully constrained. We're going to extrude that up 0.429 minus 0.402, just that tiny little bit. So 0.429 minus 0.402. So let's fillet this. 0.125. And then this needs to be cut off, and then this is going to need to go over. I'll probably just put a sketch on it, project it, extrude it to that face. And then I'll put a sketch here, project it, and extrude it to this face. And then mirror this stuff to the other side. I don't think it wants the fillet, but I need the fillet. So I think I'm going to have to roll back in time and mirror this first. then add my fillet. And I'll tell you what, since we can't mirror this, I will change my start plane to here on both of these features, and then I don't have to mirror them. Which I could have mirrored them too, because now I don't have to include that fillet. All right, I think that is it except for the fillets. And I'm not going to do the fillets yet. I think I'm going to wait till the end. Let's save this. And we'll come out on the end and start working on this shape. We could do an equals, or we can do a vertical, and then to center from base 0.812, a radius of 0.5. What am I missing? The angle constraint. I still need an equals between the two of them. There, I think that's our shape. And that's going to get extruded back. Okay. Then I just need to taper them. Well, before I taper them, I'm going to put the hole in, because then I'm still dealing with straight edges. 0.627. Oh, I don't want to go through all. Just want to go to here. Now I think it's safe to taper, so I'll do a draft, a fixed plane from U, and I think I can do U at the same time. And are they the same angle? 85 and 95, 5-degree taper. Okay. Let's do the holes yet, and then I think we're ready to all right. So when I have a series of holes, I usually use rectangles and such and turn on center points, and then the hole command will find these center points. So it makes it a little bit easier to lock a part down. This whole series of holes. 1, 2, 6, 1, 2, and 1.368. Off the end, 1.609, and we have center to center on the bolts, 1.625. So since I have these these center points, when I go to the hole command, it finds them all, and then I can say through all and type in what it's supposed to be. I'll do the counter bore over here. I think I'll mirror it to the other side. 6, 8, 5, and then that's going to be extruded up with a taper of 6 degrees. think that's what we're after. And we'll mirror that to the other side. So we need some fillets yet. These are easy. Hit save. I think I'm going to do these tiny ones in here first. So this, and this, and this, and this, and this, and this are all 0.03. And then this is 0.125, and running along here is 0.125, but they have, this is going to give me sharp corners, and they don't have those sharp corners, so that means this fillet needs to be done first. So this edge, and we'll do these two edges, and this edge are 0.063. And then we'll do the 0.125s. Doesn't like it. Let's just try this as 0.125. It's okay with that. And now it's okay with that, but it wasn't okay when we had them all picked together. And wait, I think we're done. Oh no, looks like they ran a bit into the front and rounded it off at a 45. And I don't have dimensions on that, so we'll just break the edge. I'm not going to take the time to add the dimensions to that. F7, project U, that's not what I wanted. Project U, and U. So we're just going to draw a line in here. And actually I wonder if that 45 is from here or from true vertical. Let's try it from here first. Oh, it does have a dimension here of 0.092. I guess that is dimensioned. And I'm going to probably need an axis through here. I don't think I can revolve. Yeah, I need an axis through here. And then revolve about that axis. The axis has to be above my sketch for some reason as a cut I think that's what we did. Yeah, I think that's what they did. So the tool came in normal to the hole, even though it was at a 5-degree taper. I think that's right. I'm going to turn this work access off. All right. Again, in all of these, I could have missed a dimension. I could have typed something wrong. We're not making this for production purposes. This is just for fun, for modeling. I love taking random prints and seeing how it goes, how you go about modeling them. So I'm going to stop the video here, and then in the next video, we're going to take this into the assembly environment, put this all together, and make it work. Hope you have fun modeling.